Hello everyone. I would like to welcome you all in the lecture series of Training on Competitive Examination. In this session, I am going to discuss most important equations in the area of electrical machine. So I have listed out various equations of DC machine, then AC machines and transformers. Before appearing for any competitive examination, I request everyone to go through this important equation and kindly remember these formulas. The first one, there is a relation between electrical and mechanical angle. Okay, so you can see the difference between electrical and mechanical angle by using the given formula. So as you can see, the formula is theta E, that is given by P by 2 into theta mechanical. So theta E stand for electrical angle. Theta MECH means mechanical angle. Okay, P we can call it as pole. Theta is equal to P by 2 into theta mechanical, or else you can write in reverse manner. Theta mechanical is equal to 2 theta E divided by P. Next is the terminal voltage of DC generator. So terminal voltage can be written as the generated EMF minus armature voltage drop, IA into RA. V is equal to EG minus IA into RA. This is very important. Okay. So you can note down what is EG means generated EMF, IARA means armature voltage drop, RA means armature resistance, IA means armature current. Okay. So let me discuss the remaining equations. Kindly note down these important equations for you. Similarly, if I talk about DC motor, then here the sign will be different. In terminal voltage, you can write V is equal to EB plus IARA. So that is the difference, where EB means back EMF. In the previous case, it was EG in case of generator, that is generated EMF. But in case of DC motor, it becomes back EMF or counter EMF. Fine. So make a note of this. Next is another equation for back EMF. That is EG is equal to Zn 5 by 60 into P by A. This is another important equation. Here Z is nothing but number of conductors. N is the speed of armature. Okay. The rotation, speed of rotation of the armature. Then phi is the flux per pole in Weber. P is the number of poles. A is the armature conductor per parallel path. For example, if A is equal to 2, that means it's a wave winding. If A is equal to number of pole, then it is known as lap winding. So that point you have to remember. There are two types of winding in case of armature. One is lap winding and another one is wave winding. Similarly, from this equation, I can write one more type of form. That is, the speed is directly proportional to EB and which is inversely proportional to flux. N proportional to EB by phi. Whenever you are plotting the characteristics curve of motor, this equation is required. Okay, this formula is required. That point also you have to remember. So another one is there are two types of armature reaction like demagnetization effect and cross magnetization effect. Let me talk about one equation related to demagnetization ampere turns per pole. That is ATD. ATD can be written as ATD per pole can be written as phi m into Zi by 360, where phi m is the maximum flux, Z is the conductor, I is the current. So we can define if it is IA, if it is a simplex wave winding, the current will be IA by 2. If it is simplex lap winding, it will be becoming IA by P. Like that, you can note down. Okay, for lap simplex wave winding and simplex lap winding. Fine. So another one is very important equation, torque equation of DC motor. So that is TA is equal to 0.159 into 5Z IA into P by A. This is very, very important. Phi is the flux, Z is the conductor, IA is the armature current, P is the number of poles, A is the armature conductor per parallel path. The unit of torque is Newton meter. This point also I request you to note down. So compared to armature torque, the shaft torque is little bit less. You can calculate the shaft torque by using the formula 9.55 into output by N. Output you can write in terms of EB into IA. That will be the output power. Fine, output. So you can remember this formula. Unit is Newton meter only. So I request you to note down these points. So another formula for back EMF, that is EB. So EB is equal to Zn 5 by 60 into P by A. The formula will be 100% similar that of generated EMF. So you can operate the DC machine as DC motor and a DC generator. If I talk about a DC motor, it is EB. If I talk about DC generator, that becomes EG. That is a difference. That point you have to remember. Okay. Similarly, I have already mentioned the equation N is directly proportional to EB and which is inversely proportional to flux. Another important formula which is happening in case of DC machine, hysteresis loss. WH can be written as eta into V max raised to 1.6 F into V watts, where eta is known as Steinmer's constant. Similarly, there is another formula for closed magnetization ampere turns per pole, that is ATC per pole. ZI into 1 by 2p minus theta m by 360, where theta m is known as mechanical angle. Okay, already mentioned mechanical angle. Fine. Okay, that is also another important point. If you are preparing for gate examination and all, these kind of formulas are very important. So another formula I would like to mention you that commutation. So in the commutation, you can remember this formula. So that is L is equal to L into di by dt. That is VL. Okay, that is L into 2I by TC. That is TC is known as commutating period, or you can write 2Li by TC. So this formula is also very, very important. So if you are planning for writing gate examination, so these kind of points are very important. Now I am going to enlist the various equations related to three-phase induction motor. It is an AC machine. So the important point is percentage of slip. So Ns minus N divided by Ns into 100. Ns is known as synchronous speed. You can calculate it by using the formula 120 F by P, where F is the stator frequency, supply frequency, and P is the number of poles. Ns minus N is known as slip speed. Okay, difference in synchronous speed and rotor speed. Ns synchronous speed, N is known as rotor speed. Okay, then you can calculate the frequency of rotor current by using the formula F dash is equal to S into F. So the rotor current, frequency of rotor current, you can calculate by using the formula. Fine. Okay. F dash is equal to S into F, where S is known as slip and F is known as the supply frequency at the stator. Another important formula for starting torque, T starting, that is equal to 3 by 2 pi ns into E2 square into R2 by R2 square plus X2 square, where R is the resistance part, X2 is the reactance part. Okay, moreover, the starting torque is directly proportional to the resistance R2. So these are the important observation you can make use of this from the equation. For example, when you are getting the maximum starting torque, when the R2 is equal to X2, you are able to get the maximum starting torque. That point also you have to remember. Similarly, running torque you can calculate by using the formula. TR is equal to 3 by 2 pi ns into S E2 square into R2 by R2 square plus SX2 the whole square. So this is called the running torque. So these are the important point you have to remember. Similarly, slip corresponding to the maximum torque. For example, S is equal to R2 by X2. Okay. Otherwise, you can mention. Otherwise, you can mention like R2 is equal to S into X2. So that is a condition for maximum torque. That point also you have to remember. So moving further. So there are different conditions. Like you can decide the modes of operation based on the value of slip. If slip is greater than 1, it is very clear that motor is at braking operation. If the slip values lies in between 0 and 1, then we can call it as a motor, the induction motor that works in motoring mode. If the slip is less than 1, then we can say that induction motor will act as induction generator, not in motor mode, it will operate in generator mode. So for the braking operation, slip should be greater than 1. Similarly, rotor copper loss you can calculate by using the the multiplication. If you do the multiplication of slip and a rotor input, you can get the rotor copper loss. So if you want to calculate the rotor gross output, you have to multiply 1 minus slip into rotor input. So you'll be getting rotor gross output. So later what you can do is you can calculate the rotor efficiency by using the formula 1 minus S is that is equal to N by Ns. Okay. So 1 minus is equal to N divided by Ns. Then you will be getting the rotor efficiency. Kindly note down these important points. This will be really helpful for your competitive examination. Moreover, the ratio, you can see one ratio, that is also very important. Rotor copper loss by rotor gross input, that is equal to S divided by 1 minus S. Okay, these things and all you can obtain from the circle diagram. When you are learning about circle diagram, you can calculate different parameters. So there is very, very important relation, that is P2 is to PM is to PC is equal to 1 is to S is to 1 minus S, where S is known as slip. That is very essential point. Similarly, one terminology called synchronous watt, you can calculate it by using the formula. It can be calculated by using the formula rotor copper loss by slip, that is equal to PM divided by 1 minus S. That is called a synchronous watt. That is also very, very important. So kindly make a note of this. So these are the important point which is related to induction motor. Now I'll be discussing the important equation related to AC generator, or you can call it as alternator. The frequency of AC voltage generation, that is given by F is equal to PNS by 120. Similarly, pitch factor, Kp can be written as cos alpha by 2, pitch factor. Okay, where alpha is known as electrical angle, Kp is equal to 1. If it is Kp is equal to 1, then it is known as full pitched coil. If Kp is less than 1, then it is known as short pitched coil. So these things and all you have to remember whenever you are doing the problems. So for numerical example, this is very important. Another important factor is called as distribution factor. It is called Kd, sin m beta by 2 divided by m sin beta by 2, where beta is known as slot angle, m is the number of slots per pole per phase. Similarly, voltage regulation you can calculate using the formula by taking the difference between no load voltage by full load voltage by full load voltage, that should be multiplied with 100. Please make a note that voltage regulation value should be as minimum as possible. Very less voltage regulation means efficiency is very high. Okay, the requirement is less voltage regulation. Value of voltage regulation should be as minimum as possible. Similarly, for non-salient pole type machine, you can calculate the output power by using the formula EV by XS into sin delta, where delta is known as angle between the E and V. Okay, the sending and receiving end voltage. V is the terminal voltage, E is the generated EMF. You can write sending or receiving end voltage, not a problem. But remember that V is the terminal voltage, E is the generated EMF. So like that, you can write this equation. This equation is very important for power systems also. Similarly, EMF equation of alternator you can write E is equal to 4.44 into F into phi into T into Kp into Kd. Kp, Kd we already discussed. Pitch factor and distribution factor. Phi is the flux. T is nothing but it is the ratio of Z by 2. That means the combination, one conductor means two coil. Two coil is nothing but one conductor. Okay. T is nothing but turns. Or you can write Z is equal to 2T. Anything is okay. At least you have to remember this formula. So these are the valuable equations from the topic alternator. Now I am going to show you the important formula related to transformers. It is a static device, unlike the previous machines. So first of all, you have to remember one equation called the transformation ratio, K. V2 by V1 equal to N2 by N1 is equal to I1 by I2. V2, V1 means secondary and primary voltage. N2 and N1, secondary number of turns and primary number of turns. I1 and I2, primary current and secondary current. K is called the transformation ratio. Okay, if K is equal to 1, it is an ideal transformer. If K is less than 0.5 means it's a step down transformer. If K is above 0.5, we call it as what we can say step up transformer. Similarly, EMF equation of transformer 4.44 F into N into phi m. Okay, phi m is known as the maximum flux. Similarly, you can calculate the hysteresis loss using the formula PH is equal to KH into B max raised to 1.6 F into V. This is called the hysteresis loss, which is happening in the transformer core. Similarly, eddy current loss, which is happening in the transformer core, can be written as KE into constant. It's a constant. B max the whole square F square into T square. It will be depending on the frequency as well as the thickness. That is why we are providing the laminated core to minimize the eddy current loss. Similarly, efficiency at the maximum load can be computed using the formula X into full load VA into power factor by X into full load VA into power factor plus PA plus X square into PC. Here you can give the loading, for example, 10%, 20%. Depends on the loading, you can give the value and you can calculate the efficiency. You may get these kind of questions in the form of problems. Similarly, the condition of maximum efficiency, variable loss is equal to constant loss, or you can write the variable loss X square into PC, that is equal to PI, iron loss or constant loss. From this, you can compute the value of x square root of Pi by Pc. This is a condition for maximum efficiency. Similarly, if you talk about the distribution transformer, okay, distribution transformer, we need to use all day efficiency. Output in kilowatt hour divided by input in kilowatt hour. It is expressed in terms of energy. That point also you have to remember. Okay, we have discussed about all day efficiency. Similarly, there is a single winding transformer called auto transformer. It is mainly used for voltage controlling purpose. Okay, you can change the voltage from lower level to higher level. Okay, it is having only one winding. Okay, one winding will be segregated for two. Okay, primary side and secondary side. There are saving of copper. So we can see the equation which depicts saving of copper. Weight of copper in the auto transformer is equal to 1 minus K into weight of copper in the ordinary transformer. This much of saving can be achieved. Similarly, power transferred inductively, that is equal to input into 1 minus K, where K is the transformation ratio. Power transferred conductively is equal to K into input power. So like that, you can write a few equations which is applicable for auto transformer. So I request everyone to note down this equation. There are many more equations, but I feel that these equations are most important for your competitive examination. You can have a look on the last moment. Let me know if you are having any questions. In the next session, I'll be coming with most of the important equations from power systems. So keep watching. Thank you for listening this video. All the best for your examination. Let us meet in the next session. Thank you.